So we are starting logarithms. Now, like logarithms is actually a way of writing power, right? Now when we write something like we have a base and there is power on it and it is equal to r. Base with power is equal to result. Now, what happens when we change it into log form? Then we write here log, right? This is the base, so it becomes the base of log. And this r comes here and power is here. So in other words, you can say that power is equal to log b of r. So whenever you have to change index form to log form, then you have to use the same method, that you have to write base as a base of log, this base as a base of log, and whatever the result was there in the index form is to be written over here and is equal to power. So it is logarithmic form. Now, um there are certain conditions, right? You must have to remember. And those conditions are that this the value of b, this b cannot be, when you write in log form, b cannot be 0. B is not equal to 0. B must be greater than 0, right? So it means that it cannot be negative, right? And it is not equal to 1. This base is not equal to 1. These are the three conditions for base. There are certain conditions for r as well. R must be greater than 0, right? Which means that R cannot be 0, R is not equal to 0, or R cannot be negative. Now, why is it so? You see that whenever, if we have 2 power 4, it is equal to 16, right? We will never get the number as this r cannot be, the result cannot be negative if we are putting here the power positive, right? If the power is positive or negative, we get the answer as positive. So this is not to be negative. Is this clear?
Yes.
So if we have to write this in log form, we will be having log to the base 2 with power with here 16 is equal to 4, right? We must have this positive, we must have this it cannot be 0, it cannot be negative, and it cannot be 1. Why it cannot be 1? Because 1 power 4 will be 1, 1 power 8 will be 1. Whatever the power of 1 you will be taking, it will give you the result as 1. So base cannot be 1, and base cannot be negative as well when you write in the form of log. Now, if we have something given and we have to convert into log form, you can do easily. If it is given in index form, you can convert it into log form, and if it is given in log form, you can convert it into index form. Like if it is given log 2 and then 8 is equal to 3. So how you will convert it into log index form? This is 3. This would be the power of 2. So write 2 power 3 and 8 as it. So 8 is equal to 2 power 3, that is 8. So this is the way you write in index form. So whenever you have to write in, convert or log it to index form, this will remain as it is. This 3 will become the power of 2, and then you have to remove this log. Like here what we did, we wrote 16 here, 4 here, and that 2 becomes the base of log, right? You can do it in this way. If you is equal to 16, you can write it as, you can write on this side log 2 of 16, apply log with this, and here you can write 4. So it will be easy to remember. You see, 2 you have written 2 as base here, and 16 is all 16 was already there, and you have written here 4. And when you are converting this, then what you are doing, you are writing 8 as it is, and you are writing 2 as power of 3. You can remember this, that this is B power P is equal to R. In this way blood pressure rise. You can, in this way you will be able to remember the order. And if you are writing in log form, then it is boil rice perfectly. So if you'll remember these two, then you will remember the order. BPR, B is base, power, result. And here log to the base B, result and power. So with the help of this, you can solve different questions. Like if you have to find out the value of x, and it is given log 3 of x is equal to 2. So x is equal to, you will write here x 3 power 2. So x is equal to 9. You can easily take out the value of 1. Now if it is written log x is equal to log to the base 1 upon 2 with 16. So it means that this is base 1 upon 2, this is the power, is equal to 16. Then you can write it as 2 power minus x. You will take 2 to the numerator, so it will become 2 power minus x, and this can be written as 2 power 4. So minus x is equal to 4 and x is equal to minus 4. Whenever bases are same, then we can equate the powers. So in this way you can find out the values of x. Okay, tell me one thing. If I write here log 2 and equal to what? What is what is the power of 2 which will give the result 2? 1. So you must know the answer of it, that if it is written log 2 of 2, it is to be equal to be 1. Okay, if I write here log x of x, what will be the power of x which will give you the result x? It would be 1. In the same way, if it is written log, any number is written here and here it is same, both the numbers are same, it means that the power is 1. Now if I write here log 2 8, can you write down its answer? You know what is the power of 2 which will give the result as 8? 3. If it is written log 5 of 125, what is the power of 5 which will give 125? 3. In the same way, if we have log 2 1 upon 8, what would be the power which will give the result as 1 upon 8? Minus 3. Whenever it is a fraction, then the power is to be negative. If it is written log 2 of log 10 of 1 upon 100, then we have, it means that minus 2 is the power. That's why the result is 1 upon 100. Whenever we get here fraction, then the power is to be negative. Okay, one more thing. if I write here, if it is log 2 and here it is 1, what will be the answer? What will be the power of 2 which will give the result as 1?
1.
0. 2 power 0 is equal to 1. So log 2 of 1 is equal to 0. Whatever number is written here, if here it is written 1, then the power is to be 0, because this is the result of this power. And when the power is 0, the result is 1. No matter what number is over here. Log 5 of 1 is equal to 0. You will be able to do exercise 3.3 using all these concepts. Like if it is x power 4 is equal to 2 minus k, you have to write it in index form. Then what will happen? This will become log to the base x, and 2 minus k we will write in the bracket, and here will come 4. So this 4 will be equal to log of x 2 minus k. Using this concept, you will be able to do exercise 3.3. There are two different kind of logarithms: common logarithms and natural logarithms, right? In this, when the base of the log is 10, right, then we say that it is, we write it as lg. Lg 10 is equal to 1, right? In common logarithms, base is 10. Here, in this case, base is 10 in this case. And in this case, base is e. You people have done e, you people know, you people have already done exponential. So when the base is e, then we say it is natural logarithm. And how can we write it? We can write it as log to the base e, and log to the, if here also e, then we say it is equal to 1. And we can write it as ln. Log e will be written as ln, and log with the base 10 can be written as lg. So whenever it is written lg, it is log to the base 10, and whenever it is written log to the base e, it is ln. Clear? So you must know the difference between lg and ln. The base is already there. Whenever the bases are other than this, then we have to write the base. If the base is 2, 3, 5, 7, or whatever, then we have to mention. But if the base is 10, then we simply write lg10. And the way, when the base is e, we simply write ln e, right? So whenever we have these two same, we write the answer as 1. So lg10 is equal to 1. In the same way, we have log to the base e, and e is equal to 1. So we can simply write ln e is equal to 1. So whenever you will get somewhere lg10, the value of lg10 is 1. And where do we apply this? If we have the questions in which, like, we have 5 power x is equal to 9. We have 5 power x and we have 9 here. We cannot make the bases same. Like in the case, if we have 5 power x is equal to 125, then what we do, we write 5 power x is equal to 5 power 3, and we write x is equal to 3, right? We cannot make the bases same here. In that case, we apply LG on both sides, right? Or you can convert it into log form. Apply LG on both sides. So when we will apply LG, it will be LG5 to the power x is equal to LG9. And then x will go before this, and so it will become LGx LG9, and x is equal to LG9 upon LG5. And this you have to take out using the calculator. Now, when you will enter in the calculator, then you have to use the key where it is written log, and you will be writing LG, and you can write it in the fraction form if you have the calculator with fraction. So LG 9 upon LG 5, don't forget to close the bracket. LG 5, you will be getting the answer 1.365. So 1.365. You have to write down the answers to three significant figures. So it will become 1.37. So this is the answer. Now, you cannot apply log on both sides not if the single terms are not there on both the sides. 2 here, and it is multiplying by 3 power x and is equal to 5, right? So you cannot apply here log. If you will apply here log, then you have to use here product rule. You have to, whenever you have to apply log, your equation must be in the form b power bp is equal to r. Then you will be applying log on both sides. Now there are laws of logarithm. We have four laws of logarithm. One is power law, right? In power law, if we have a log to the base b, and here we have r is equal to p. If we have any power over here, then that power can be written before log, right? This power can be written before the log. So this is called power law. Then second is product law. If we have log b and here we have xy, right? Now we will be, when we will be separating these two, we will be writing log b of x and we will be writing log b of y. As there is multiplication, so we will put here plus sign. So this is called power law. Then third is quotient law. In quotient law, if it is log b x upon y, then you have to write log b x, log b y. So there is division, so you'll be writing minus sign here. So then you'll be solving the question. Okay. Fourth law is change of base law. That is very important. What happens if you have log to the base b and here it is r and you want to change this base? Then what you can do, you can do it in two ways. One is that you can write it as 1 upon, if you want to make this as base and this you have want this r as base, then you can take it to the denominator, so it will become log r and b here, right? One of the way is this. Another way is, if this is written like this, then you can write it as log to the base, you can write it as log to the base b upon log r, and here you can put any base, either you can put 2 or you can write it as lgb upon lgr, or you can write lgr upon lgb, right? Or you can write ln r upon ln b. You can write any base. right? You can write it as log to the base 5r upon log to the base 5b. So you can make the bases same in this way, right? So this is change of base law. Either you change it like this or you change it like this. You write r in the numerator and b in the denominator and put any log to any base over here.